Hello and welcome to this fifth part of the Java FireSimulation tutorial. And in this part we will make a new class called cells, and that class will take a one-dimensional array as input, and then it will manipulate the cells and return a one-dimensional array. So before we get starting actually creating it, I want to show what the purpose of this is. So let's see if we can find some things to draw with here. And I'll draw it out for you guys. That's way too big. Let's see. I'm not satisfied with. Let's take this, but let's make it a bit bigger. There we go. It's okay. Okay, so let's see if we can get a nice color. Yeah, cool. Okay, so we have our whole cells. This is our board. We have a lot of cells in it. And this, if people are familiar with image processing, this is a type of image processing called neighborhood operation. And it's kind of like using a kernel for example, what can I say, blurring, mean operation, some edge detection, stuff like that. So let's say that we have some numbers in here. We have 4, 5, 4, 5, 5, 5, 4, 4. Let's say 4, 5. It doesn't matter, these numbers here, like. Okay, so we have a lot of numbers. And what we want to do is, when we get to this number here, for example this number here, then depending on the surrounding numbers, we want to change this number 5 in here. So therefore it's called neighborhood operations, because it's the neighboring cells that we are actually depending on. So let's say that this number here is 5. Then we want to want to check that 5, that's a pine tree. And what happens if it's a pine tree? If it's a pine tree, it has a very, very low chance of catching on fire. That is like if it's hit by thunder, then it will catch on fire. And there's a small chance of that. So like thunder, there's a 0.0001% chance that it catches on fire. That's really low. So every time we get a 5 in the middle cell, we'll have to check if this number, like if this change is happening, and then it will catch on fire and change to I don't know, 1 that is fire. If it's not catching on fire, then we check the surrounding cells, and if one of the surrounding cells is fire, then there's a 10% chance that this cell will turn into fire, and otherwise it will just remain a pine tree. So we need to look at all the other surrounding cells and check if one of them is fire. And we have to do this with everything. So with water, we have to check if any one of the surrounding ones are like fire, because then the water will turn into ground. Therefore we need all the time, we need to check what is happening with this cell, 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 and this cell here. So these are all the 8 cells that we want to check stuff with. Now the hard part is, what if our red cell, let's see here, what if our red cell is this cell up here? Then we'll have to check this cell here, this cell here, this cell, and ooh, there's no cell out here. What are we going to do? Then we have to check this cell over here. And about this cell, we'll have to check this cell over here. Cell above it, we'll have to check the below one. This cell out here, we'll have to check this cell out here. And then what about this one here? Well, we will have to check this down here. This is so we can actually wrap around the picture, because if this was not true, that we could not wrap around the picture, then the outer row, let's find another color, this one here, then the outer row here could never change, because the first cell we can actually change is like this row in here, because they can touch they have outer cells. We could also just say that they are always like trees, for example, but that will get boring. So therefore we wrap around, and we need to check these things here. So I hope this could be explained. I hope this is easy to understand. Else you'll probably get it when we go into this the thing here. So let's make a new. Oh, gotta put this drawing board away. There we go. So let's make a new class and called cells.java. Okay, and this class, it's a public class, and it doesn't extend anything, and it doesn't implement anything. So in this, we want some variables, and we want an array, because we will pass in an array, and we'll use that array and turn that array. So let's make a private int array. Let's call it surrounding cells. Surrounding cells, yep. And that's all the cells surrounding it, including that in the middle. So it's a new int array, and there's 9 cells in it, because as we could see there's 8 around it plus the 9 in the middle. And then we want a private int called cell state, and that cell state is the middle cell. So let's see here. Now we want to make a constructor that runs through all of this. We could split it up into a couple of methods, but let's just keep it in the constructor. It doesn't really matter. So let's make a public cells, and it needs a one-dimensional array for surrounding cells, and that's it. I think I did this wrong. I think this needs to be here. There we go. If I'm correct. This is always a pain if you have done C++, is to figure out where these square brackets are supposed to be. So, and let's say this dot surrounding cells is equal to surrounding cells, because in this constructor here we have a variable called surrounding cells, but this is only accessible from within this like method or constructor. But we want to use it outside this constructor too. Therefore we call this, which refers to the classes variable called surrounding cells. So we set the class surrounding cells equal to the methods surrounding cells, and then we can use it everywhere. And let's set cell state equal to this, so the classes surrounding cells, and it needs to be the middle one. So if we look at like I don't know, 3 cells, we have number 1, number 2, number 3. No, sorry, that's it's not right. Of course we start at 0, 1, 2, 3, 4, 5, 6, 7, 8. So number 4 is the middle one. So that's number 4. Okay. And then we need some random numbers, because we have to check if all of these percentages, if they're true or false or stuff like that. So we need random, new, random, and remember to import java.util.random. There we go. Now we can use the random ones, and let's make a switch case that checks 7 different things. It needs to check if it's wall, fire, ash, ground, tree, pine tree, and did we have any more? I forgot to count. And water. I think that's it. Isn't that 7? Yeah, that's 7. Okay. So we check the cell state because we check this middle cell, what that is, and depending on what that is, we will do stuff. So let's say that case, oh, not class, case 0, that will be something, which will be cell state is equal to 0. So if the case is 0, that's a wall. We can write, I don't know, let's write it here, like wall. So if the cell is a wall, then it will stay a wall. It will never change because the wall cannot burn. No matter how hot it is outside, the wall cannot burn. And then we break. Then we make a case for our fire. So let's make a case 1. And let's see, okay, here we need to check if the surrounding cells are if any of the surrounding cells is equal to fire. If they are, no, sorry, I'm jumping around and what's what. If any surrounding cells are water, if they are, then the fire will turn into ground and the water will turn into ground. And how do we do this? Well, we can use an enhanced for loop that just runs through the cells. So let's make a for, and let's say int I, and let's use this dot surrounding cells. And now we can check that if I is equal to 6, 6 will be water. Maybe we should like write them all down just so we can remember that. So 1, wall equal 1, fire equal 2, ash equal, there's something wrong here, 0, 1, 2, ground equal 3, tree equal 4, pine equal 5, water equal 6. So if any of the surrounding cells is equal to water, then the surrounding cell, which is called I, will turn into ground, and the cell will turn into ground. So that's pretty simple. But we can also check that if I is not equal to 6, so if not equal to water, then, and this is the fire, then we will say, then there's a 30% chance that it will turn into ash, and else it will just stay fire. So if there's no water around it, there's a 30% chance it will turn into ash. So therefore we can say rand dot next int, and I know this is not really 30%, this is 33%, but whatever, close enough. And let's say cell state is equal to 2, because then it will turn into ash, and let's say else it will just stay fire and continue burning everything down. And let's break this after here, break. Yeah, that's the correct place. All these curly brackets, it's confusing. So let's make a case number 2 and just write what it is. It's ash. And for case number 2, we can say that there's a 1% chance that ash will stay ash, and then there's a 99% chance that ash will turn into ground. So for the most part, ash will turn into ground. So rand.nextInt 100, and if that is equal to 0, so that's 1% chance that if we take a random number between 0 and 100, it will be 0. Or 0 and 99, but still the same. And we'll turn it into let's see, ash, and else it will just turn into ground. Okay, so now let's move on, and let's say that we have a case for ground. Say the case 3. So there's a, for the ground here, I have a PDF with some of the numbers on here. Let's see here. Okay. So if the cell state is ground, then there's a 0.4% chance that a tree will spawn. There's a 0.1% chance that a pine tree will spawn. And there's a 99.5% chance that it will remain ground. So there's a really, really, really low chance that trees will spawn. So how can we do this? Well, we can say that we first check if for the 0.5% chance that a tree will spawn. So we can do that by say random nextInt 200 is equal to 0. Now this is, if this is true, that we get a 0, that's a 0.5% chance. We can say if rand.nextInt, and we can say out of that 0.5% chance we take 20% chance, and if that's 0, then we will turn it into a pine tree. And then else we will just turn it into a tree. Not tree, but like cell state 4. This might have been easier if you used some enums, at least easier to read, but I don't want to go into that right now. So, and if that 0.5% chance does not occur, then let's just keep it as ground. Oh, it's a long one, this one here. It's 2 more left. I think we can make it. So, say ground, the next one is tree, case 4. So in this case here, if a tree is happening, then there is a weak chance, like 0.0001% chance that will burst into fire because it's hit by thunder. And if there's one surrounding cell, which is fire, there's a 30% chance that the tree will catch on fire. The pine tree will only have a 10% chance, so that's a bit lower, that will catch on fire. So let's see here. Let's make again to check all the surrounding cells. And remember, it's this that's surrounding cells. Then say if I is equal to 1, that means there's a fire around. Then we have a 30% chance. Rand nextInt 3, 0. That's a 30% chance that the cell state will be equal to 1, because then we'll catch on fire. Else it will just stay a happy tree. Okay, and when we've done this, we also just want to make sure that it maybe catches on fire if we're lucky. But this is really low chance. So let's say 1 in 100,000. That's a low chance. The cell state will be equal to 1. Let's break that. And let's see. Let's make the pine tree. So let's make a case number 5. And let's do kinda the same. So to save time, I'll copy, paste, and this is not a 30% chance, it's a 10% chance, and it will stay a pine tree, and it has the same percent chance of getting hit by lightning. Okay, and let's take the last one. This is water. This is case number 6. Take the time. This is really long. Int I. Let's check for this, that's surrounding cells. And if any of the surrounding cells is equal to fire, then the water will turn into ground. That's just it. Or no, I'm sorry, that's not correct. If water will remain water unless there is a surrounding fire, and then it will turn into ground. So if I is equal to 1, that's one of the surrounding cells is fire, then the cell state will be ground, which was 3. Else, cell state will happily stay water. So let's break this. And now we are almost done. We just need to make sure that this is inside our there we go. Yep, like this there. Since our switch, so this line down here stops here. Okay, so we say this dot surrounding cells number 4, so that's the middle cell, is equal to our cell state. So remember to set the cells like this place in the array to the surrounding cell, to the cell state. And then we go out of this, and then we are ready to do the last magic, and that will be inside our constructor too. We will say let's see here. No, it's not inside our constructor. Yes, it is. Okay, so this is correct. This closes our, no, so this is not correct. It should not be inside our constructor. Let's make it here. Let's say public int, and we need to return a normal array, or so therefore we say return cells, and we just return this dot surrounding cells. And now when we call this, we actually return what we got in here. So that's our cell function, or our cell class. It's a bit long, but I hope it makes sense. We can go through it digital paper later on when we actually start to do some testing with it. But for now, that's it, and see you in the next one.